Introduction to electrostatic. Electrostatic is just a fancy word of saying static electricity. So we're going to learn about how this interaction between a neutral yellow balloon with a neutral sweater. And neutral means that we have the same amount of plus signs, which stands for protons, as we do the negative signs, which indicates the electrons. So here we have 4 protons in the red, and we have 4 electrons in the blue. So we're neutral. If we look at the sweater has the same number of protons as it does electrons, making it neutral. Everything is neutral in the world until things are charged and build up. So basically what we want to do is always make sure that everything's neutral. And the way we do that is by being grounded. The ground has an infinite number of charges that supply us whenever we have too much or not enough. So we always ground things in order to go get electrons to balance us out. So how does one become in balance and be able to, 1, shock us by touching us, or 2, get electrocuted when we touch a wire? So basically what we're going to do is charge it up, and the way we're going to charge it up is we're going to rub it on the sweater. So we're going to rub this on the sweater, and after we rub it, you can see as though that by rubbing it, we picked up electrons from the sweater, or we take electrons from the sweater. These are the words that you're going to be familiar with. As you can see, we ended up gaining 8 more electrons and left the sweater with less electrons. So, and basically what we want to say is that this yellow balloon is now as a negative 8 charge, and the sweater is now a positive 8 charge. So as we can see, if we take a look at it, that the protons don't ever move. They are bounded into the nucleus, so they'll never move. So if I just go and I rub a little bit more, as you can see, the protons did not move. All the electrons are on the yellow balloon. However, we still have our original 4 protons. You learned this from Miss Moots. Protons are in the nucleus and they're bounded there. Electrons are on the outer shell in the orbit, so they're the ones that are sharing. They're either gaining or they're borrowing or they're taking from other objects. So when I release it, the positive and the negative are attracted to each other. So let's reset that. When I reset it, I want you to pay attention to what happens to be able to become neutral again, what happens to the sweater and what happens to the yellow balloon, because now we're going to take these objects and we're going to neutralize them again. And the way we neutralize them is that if we look, the sweater has to take their electrons back, and the balloon has to give the electrons back in order to be neutralized. So if we reset it, the balloon gave all the electrons back to the sweater. So now they're both neutral again. So now let's take a look at 2 balloons. I have the yellow and the green balloon. Both of them are neutral. I'm going to move this one way over there. Okay. I'm going to go and rub, gain electrons, and I'm going to put it close to the yellow balloon. Think for a second, what would happen? Is it going to attract, repulse, or remain the same with the yellow balloon? What is the interaction of the yellow balloon with the sweater, and what is the interaction of the green balloon? So take a moment and think about what would happen. Is the yellow balloon going to move? Is the green balloon going to move? Are they both going to move towards the sweater? It was only the green balloon. Ask yourself, why didn't this yellow balloon move? Well, it's because it's neutral. So let's go gain a couple of electrons. Okay, and I'm going to push it over there. And let's go put the green balloon close to it now. Okay, green balloon is, oh, it's attracted to the sweater, but the yellow balloon's coming. Let's go put the green balloon over there. Why is this happening? You're absolutely right. It's because they're both negatively charged. The green balloon has a negative charge of 9, and the yellow balloon has a negative charge of only 6. So it's trying to move away from it. Okay? So here, I'm going to rub some more. And that yellow balloon is going to stay clearly away from it. But let's move it over here. Oh, uh-oh. Okay? So let's reset it. And let's take a look at the amount of force that an object has with what we call the force, how much attraction and how much repulsion it has when it's close to it. So let's go charge up the yellow balloon. I'm going to charge it up. And let's move it over here. And what we're looking for is how much attraction we have between the positive and the negative. And so what you're looking at is the force of how much this sweater is pulling the yellow balloon towards it. Ask yourself and think about it. How much force is it when it's farther apart? Is it more force or less force? And when does it really gain more force? Does it gain more force when it's farther away or when it gets closer? Okay, let's see that again. Let's try to get just maybe a couple of them. Let's see it again. You're absolutely right. When it's farther away from the sweater, it has less force of attraction because it is smaller in charge. It only has a -7 here. So the force away from it, if you push them apart and you separate them, then it's harder for it to attract it to pull the yellow balloon towards the sweater. Okay, it's going to take more charge. So let's go and let's get some more. And let's see what happens when we add more charge. Now we have a -20 on this yellow balloon. And let's see the force of attraction now. Okay, we have a larger charge. A larger charge on the balloon causes for a larger attraction. So we can see. So let's reset it and let's just go get a couple so we can see it again. See how there's less force away, and as it gets closer, it then draws in more force. So this is an example of a balloon, a neutral balloon, and a neutral sweater. If we were to add a wall to it, okay? Now, what you're observing is first, if I come over here, nothing's happening to the wall. So we need to keep an eye out for the electrons because remember, protons do not, you're right, move. They don't move. So we want to pay attention to the blue electrons, the negative charge. Okay, we're going to go charge it up. We're going to charge it up. And by charging, we're building up electrons by friction. So now let's pay attention to what happens with the wall. In order for you to get your balloon to stick on the wall, you have to build up your charges on your balloon so it's not neutral anymore. So let's go see what happens. So as you can see right here, the electrons push away because electrons repel these electrons. These protons stay there and we stick to the wall because we have this force of attraction between negative and positive. But the negative push away. So let's take a look. As we get closer, we push those electrons away and we attract the positive and that force of attraction. So you've got to be able to apply this, one, whether it's a comb in your hair, the balloon in your hair, the balloon in the sweater, the balloon with a wall, you have to look at this as how these electrons are transferring. Are we gaining electrons? Or are we losing electrons? Because protons never move. Now this is your concept of static electricity, which the fancy name of it is called electrostatic. Just flip the words around.